In this video, I'm going to work some examples that were requested by a few people. Given a graph, how do we get to that equation? And then telling between sine and cosine versus tangent and cotangent, which one to pick. So starting off, one thing you should have noticed in our videos and in our homework that sine and cosine look almost exactly the same. They just start at different places, meaning that the sine function starts on the midline starting at 0. Cosine function starts on top of the midline above it and does the exact same shape. They just have different starting points. So that makes it a bit tough. And then picking up all the information can be pretty tough. So let's take a look. I'm going to do, I think, about 10 of these. We'll go pretty quick. Some of these shifts are kind of hard to tell given the graphs they gave us. So I took a hint that they gave us, and then we'll take a look at this first one. There's no way we would be able to tell unless they gave it to us. Okay, so starting off with this graph, one thing I notice is I always pick up the period first. To me, that's like the easiest thing to see with that the pattern just repeats there. And you can see that like this is almost 0, right, if it were right there. And this is almost pi if it was right there. Those two gaps look the same. So I'm pretty sure that the period is pi. So the graph starts repeating every pi. And then the period, if we're looking at that, and this one's kind of tough to tell. It's a little ambiguous, but we're going to go ahead and say it's a 3. All right, you can tell it goes up 3 and down 3 in each direction. The midline, one thing we had to pick up is right there in the middle. It didn't get shifted up and down at all, so there's no up and down shift. Now, the hard part, if I were to cover this up, because I covered a lot of these up so we could try to look at it, I don't think I would get to that's pi over 12. So any kind of homework problem, hopefully they're being not subjective where those are at, easy to tell, because there's no way I could see that moved to the right, pi over 12. Now, this is what I was talking about here, is if they didn't give me this right, that would have like kind of kept me from looking, and this is where we can come up with multiple answers. I can see that the blue dot that I have there, let me pick different colors now, this red dot, I could say, hey, that moved over a little bit. If I were to move it to the right, I could start it right here at that, and that would be my sine function, right? Or if I took this point right here and I moved it to the left sum to put it right here, that would be my cosine function. So this is ambiguous. I could pick either one that I want. And with this photo, it's very tough since this pi over 12. So we're going to go with right pi over 12. So that means it moved to the right pi over 12. So we're looking at a cosine function, right? Because we're starting above the midline, not on it. The only reason I was able to pick that up is they told me right. Otherwise, you could pick a sine or cosine. Lumens should be able to take either one of those, or in the directions they're going to tell you which one to use. It'll be one or the other. For my test, it won't be ambiguous. It'll be some kind of matching or multiple choice or something like that. Maybe a small sketching. But I try not to do a whole lot of sketching because it can get pretty tough to grade. So it'll be a little simpler on that way with these shifts, meaning you'll have options to choose from. Okay, so moving right, pi over 12, I can see that it's a cosine because it started above. So, okay, y equals, it's going to be 3 cosine. It's starting above. Okay, this is, somebody asked also positive, negatives. How are we supposed to tell? Well, cosine starts above. So see that it starts above. If this would have been down here, in the appropriate spot, around 3, if it would have been down there, then I know it's starting the opposite way that it usually starts. So it would be a negative if that were the case. But it's not. It's starting above, so it stays a positive. I also have that if I want to move it to the right, I'm going to minus pi over 12 to move it to the right. And then we're going to have to do a little bit more with the period. So the period means, remember, we have a formula for period. Period is equal to, for sine and cosine, is 2 pi over b. And we would pick the number that would be right here, the b here, and that's what we would plug in. Okay, well, if we know the period is pi, then I'm going to put the pi here, put 2 pi over b, and then I solve my equation for b. I would multiply each side by b and divide by pi, giving me a 2. So that tells me that I have a period of 2 right there. Or not a period, but a b equals 2. If I now plug this into that formula, then it would have given me the appropriate period. All right, so that's how we do that. Again, I could have picked a sine. The only reason I didn't pick a sine is because I was unsure about the gap that is over here. I knew from the problem where I stole these that it was right pi over 12. You should be able to tell in your picture which will be the easier way to grab. All right, let's look at another one. All right, so first thing I'm looking for maybe is the midline. Okay, there's my midline. This tells me amplitude, nice and easy. The amplitude here is 2. All right, the period, so I just pick a spot and I let it repeat. Okay, it's going to repeat right there. It looked like it goes from, if I were to shift things to the left, it would go from 2 pi all the way to 8 pi, so the period is 6 pi. All I'm looking at is how far did it go between those 2 points. Right, the phase shift, okay, I have that point that I plot right here. You can see that that's moved where I could take that and move it all the way over and have it start here and grab me a sine. But I also have this point here. I could take either one and think about its shift. Okay, well it looks like it's shifting because this is 3 pi right there. Marker's kind of big, 3 pi. So it looks like it moved over a pi over 2. So we could say left pi over 2, or we moved this whole over. Let's see what their answer key said, and we'll go with that. So left 2 pi. Okay, interesting. So if you notice, okay, 2 pi is going to be this gap. So if you move it over left 2 pi, the graph is not going to be, actually don't like their answer, let's not use their answer. Okay, left 2 pi. Okay, so let's figure out this gap rather than dealing with their gap. I want to see, I'm going to move this from here over there. I'm going to put that back where it started there. Okay, I can see that each tick mark is pi. So this is 2.5 pi. 2.5 pi is 5 over 2 pi. So I know the shift is we're going to move it right 5 pi over 2. Okay, so if I'm going to move that, where I moved that right, this is the sine. So I know it's going to start with a sine. It's going to have a 2 amplitude sine. Right, that's my amplitude, we see that. And I got to figure out the period. Okay, normal period is 2 pi over b. They told me the period, or we figured it out, was 6 pi. 2 pi over b. So if I solve for b, I would times by b, divide by 6 pi. I'm going to get a 1/3. So I get a 1/3 here. And then I got to respect the shift. So the shift goes over negative or positive 5 pi over 2. But since I want it to go to the left, I'm going to put a negative. Or since I want it to go to the right, I'm going to put a negative. Got myself mixed up there. So that x minus 5 pi over 2 is going to take my whole sine function and shift it to the right, causing that point that would have been, let me erase these. The point that would have been here got moved over 5 pi over 2. I could have, like I said, this is a bit ambiguous, I could have taken this point and moved it over and said, hey, it just shifted over left however much that is, and I guess it would have been a pi over 2. Either way, it gets me the exact same graph. So, multiple answers and ways you can do that. All right, let's take a look at this one. So I think when I was making sure these problems were good, looking for that period first, I see it's here and it's here, so it goes about that much. I can see that the gaps are almost right here to right here, right? If I were to move them both over to the right, I can put them there. That's from 1 pi to 7 pi, so that's a period of 6 pi again. Okay, the amplitude, I see the midline's right on the x-axis. So the amplitude is 4. All right, again, I let them show me because it was a little ambiguous, but you can tell that this graph, if I were to zoom in here, it looks like it goes over 3 pi over 2. This is pi. So 3 pi over 4, 3 pi over 4, that sounds about right. Now again, in your homework and problems that I would give you for an assessment, these numbers would not be ambiguous at all. You'd be able to tell, or I'd give it to you. Okay, so I know that it moves to the right, so I'm thinking about what would it be if I shifted it back left. Well, I'm starting above the midline, so that tells me it's a cosine. I also know it's a 4 out front. How I determine if it's a negative? Well, it starts above the midline, so it's going to be a positive. If it would have started down here, it would have been a negative. Okay, I need to work on the period. So the period, remember that formula is 2 pi over b. The period is 6 pi, and that's 2 pi over b. If I solve for b, then I get a 1/3. So the 1/3 goes inside here. We could put that in parentheses like this. I've been doing that. That's fine. Either way is the same thing. And then I have x minus, because I'm moving it to the right, of 3 pi over 4. I chose cosine because it was above. I could have also picked sine here and moved it 2 pi and it looks like a 1/4, right? It would have been 9 pi over 4 to the right. I could have done that as well. Sines and cosines can produce the exact same graph just by a phase shift left or right. Right? We've got a handful more. Okay, the amplitude here. It's kind of debatable, but where I picked these up, that's a half, right? Again, I'll make it not subjective. The period, this one's nice and easy. It doesn't look like it shifts much. It is pi, right? We can see where it starts starts repeating. Notice that this almost looks like sine because it starts on the midline, but it starts below. So I'm going to put none here. And I'm going to go ahead and take my sine function because it starts on the midline. I know that the amplitude is 1/2. And then I want it to go down first instead of above. This is how we determine the positive. Normal sine would go up, but this one goes down. So I'm going to throw a negative there. I also have to use the period, same formula stuff, 2 pi over b. So this is pi equals 2 pi over b. If I multiply by b and divide by pi, I get 2. So we're going to get negative 1/2 sine 2, and then I use, there is no phase shift, so I'm just going to put an x. I think that's it. There's nothing left or right. We can see that I could pick a cosine and say it got shifted over pi over 4. I could do that and get the exact same graph. I could take a cosine function and move it any direction as much as I want to match that. So there's an infinite number of answers to these problems because I could phase shift to the left or right half my a full period and get the exact same graph. All right, I'm going to do a few more. I think I'm going to do, I don't know if we need to do all 10 of these. Let's go ahead and jump down and do the bottom 4 here. Okay, take a look at that one. I can see that it's repeating there. I remember I can make this a sine or cosine, but since it starts above the midline, then I'm going to use a cosine. Now, with that, we have to find this midline. I think it's like right here in the middle. Yep. Okay, so, and that's down 1. So the midline, okay, so let's do the amplitude first. The amplitude goes up 3 in each direction. The period repeats every 6 pi. And then it's a vertical shift. This time it moved down 1. So I'm going to use a cosine because it starts above. The amplitude is going to be a positive 3 because it starts above, not below. And then there is no left or right shift, but I do need to deal with that period. So the period here is 2 pi over b every time. I plug in 6 pi, and I get 2 pi over b still. I multiply by b, divide by the 6 pi, and I get, they like their thirds, I guess, on this one. So I'm going to put a third in there for b. Oh, sorry, zoomed in there. Don't know what's going on. Give me a sec. I don't know why that did that. All right, so I got a third there, and there's no shift left or right. So I'm going to put this in just to emphasize that the cosine stops there, but I know I got to go down 1, so I put a -1. I hope it's becoming a little clearer. I think the most difficult part when I was doing this as a student is figuring out those left and right shifts, and then the period felt a bit overwhelming, but once I got my hands on it, the period gets easier. Right, looking at this one. So we can see this one shift. It shifted up. The midline there is on the 2. Right there. So it moved up. The amplitude, I believe, I think it's a half. Yeah, it's a half. So my amplitude is a half. Kind of hard to see, but we would have better tick marks there to help us. The period, okay, so it starts here and it ends here. So we got to figure that out. Okay, it's kind of ambiguous here, but I'm going to show you a trick. If I keep going and matching out my periods, I can see that I covered 3 full cycles over 2 pi. So I'm just going to take my 2 pi, that's all the way across there with all my 4 red dots, and I'm going to divide it into 3, and that tells me my period. So I used the tick marks there to find an even number, and I took it and divided it by how many periods. So all the way across 0 to 2 pi, I get 3 of them in there, and I can divide that by 3, and that tells me my period. I also see that it moved up. Oops, I erased instead of writing. Up 2. Okay, so there's the up. I also see that it starts on the midline, so that tells me I would like to use sine. Okay, the amplitude is 1/2. It's not negative because it goes up first. Of sine. I got to figure out the period business, so let's do that. Period equals 2 pi over b. So that's 2 pi over 3 equals 2 pi over b, and we can just use our eyes here. This tells me if I want those to match, b better be 3, right? I need 2 pi over 3 equals 2 pi over 3, so b has to be 3. So I get 3x. It doesn't shift left or right, but it moves up 2, so I put a plus 2. Again, this could have been a cosine. I could have shifted it over in some sort, a left or right shift, to get a cosine. Multiple answers to these. Okay. First thing I'm looking for is that midline. Okay, I see it right here. Straight enough there. Actually, it's going to bother me. I'm going to move it up slightly. Okay, the amplitude here I can see is 2. The period, okay, so I got to figure out where this starts repeating. It looks like it's right on. Cool. It's a pi. So I could do period equals 2 pi over b. So pi equals 2 pi over b. I divide by b, I get, or multiply by b, divide by pi, I get 2. And then I can see the vertical shift, this whole thing moved up 2. I see that it starts on the midline, so that tells me it's above the midline. Since it starts above the midline, that tells me it is a cosine. So I'm going to have y equals, it goes up, it starts above it, not below it, so it's a positive, 2 cosine. I have b there, which is 2, and it's going to be just an x because it's not moving left or right, but it did move up 2. So there is my equation. These get a little easier with time and being able to know exactly what you're looking for. Amplitude, period, and then a left-right shift or an up-down shift. They can happen at the same time as well. I think that's happening not on our next graph, but the way we would do that is identify your midline. Okay, I can see the amplitude here is 2. The period starts here, ends there. It looks like it's every period is pi over 2. And then it moved down 1. And since it's starting right there, I'm not going to move it left or right. I can see that it's just repeating every time there. So I got to use the period formula. Period equals 2 pi over b. And then we're going to plug in pi over 2 equals 2 pi over b. For that to be true, I would need that to reduce. B has to be 4. Okay, I can see that it starts on the midline and it goes up, so I know it's a sine with an amplitude of 2. B is 4. It didn't move left or right, so I'm just going to no shift inside, and then it moved down 1. All right, there we go. These take some practice. It's just going to take some reps and getting used to it and being able to know exactly what to look for. Our book didn't do a great explanation of vice versa, so I think I missed it in the videos. So here you go. Here's more to work with. I'll also do a video on tangent as well and cotangent, moving those around.